What's up, math scholars? We're reviewing for our radicals quiz, so that'll be fun. And I decided we're going to start at the end. All the hard problems are at the very end, so we'll do the hard ones together, and then we'll pull up some board buddies to do the easier ones, okay? We just went over the homework, so this is fresh in our minds. We're definitely going to need to use a conjugate on this. It's because our denominator is two terms, and we want to get rid of the radical down there. We're going to partner it with the conjugate 4 minus radical 11. Whatever you do on the bottom, you also do on the top. So on the top, I'll have a 4 minus radical 11 as well. My board's not writing super great, but you can figure that out. All right, let's start in the bottom. Since they are conjugates, you can just do the 4 times the 4 and get 16, and do the radical 11 with the negative radical 11. So it's negative radical 121. What is the square root of 121? 11. So really, you just need to do 16 minus 11. What is 16 minus 11? 5. So 5 is going to be our denominator, our final denominator. Now we need to work on our numerator. Unfortunately, there's no shortcuts. We have to do the whole entire FOIL process. So all 4 matchups. 3 times 4 would be a 12. 3 times a negative radical 11 is negative 3 radical 11. A positive 4 with a negative radical 3 is negative 4 radical 3. And then our last matchup, negative radical 3 with negative radical 11. Positive radical 33. And there are not any like terms in that final answer, so all 4 of those terms do have to stay. All right, we're on 11. Do we need a conjugate on this one, yes or no? Yes, we do, because that denominator is 2 terms, 1 minus radical 5. So I'm going to put a 1 plus radical 5 right here and right here as well. You do the same thing on the top and bottom. This one's not nearly as lengthy as the one we just finished. On the bottom, as far as our conjugates are concerned, we only have to do the first and the last matchups. And the reason for that is the inners and outers would end up adding to 0, so we don't waste our time doing it. 1 times 1 is 1. And then positive radical 5 with negative radical 5 is negative radical 25. Now on the top, all we really have to do is distribute the radical 7. There's no foiling or anything. Radical 7 times 1 is radical 7. And radical 7 and radical 5 is radical 35. Now, do you think anybody could break out of jail for the 35 to simplify that down? No, because it's just 7 times 5. But I forgot about my bottom. What's the square root of 25? 5. And then what is 1 minus 5? Negative 4. So our final answer has a negative 4 down. All right, we're on number 10. Do we need a conjugate? No, that denominator right here is only 1 term. What do you think we want to multiply by to kind of rationalize it and get those radicals to go away? Radical 3. Yep. You'll do a radical 3 on top. You'll do a radical 3 on bottom. It will become important to use parentheses up there because there will be some distributing that will need to occur. On the bottom, I have that 2. But then I have radical 3 and radical 3, which is radical 9. What is the square root of 9? 3. So basically what I have here is 2 times 3. And 2 times 3 equals 6. So my bottom is a 6. All right, on the top, I would go ahead and multiply these 2. That does become a radical 6. And then this one times this one would be a negative 5 radical 18. Do you think I could break guys out of jail for the 18? Yeah, so somewhere where you have space off to the side, we're going to work on simplifying that radical 18. So it's 9 times 2, 3 times 3. How many do I need in a group to break out of jail? 2. There's an invisible jail guard guy saying, you need 2 guys to break from my jail. I found them. I found myself a group of 2 3s. They'll run out of jail. 1 will fall in a hole. And so this radical 18 is equivalent to 3 radical 2. That 2 stays in jail. Now, keep in mind, if radical 18 is actually written as 3 radical 2, that 5 and that 3 will multiply with each other. So we'll have a radical 6, a negative 15 radical 2, and a 6. So that 5 existed beforehand, and then the radical 18 became 3 radical 2. That's why I multiplied those together. Okay, everybody on the video, I'm going to pull up 6 math scholars up to be board buddies right now, and we'll come back at you with the answer. Hello, people watching the video. My scholars did pretty good at the board. Oh my gosh, I think we were 6 for 6. That's amazing. On the bottom, you get a square root of 4, which does equal 2. On the top, you get negative 4 radical 6, which you can't really do anything with. But then all my people at the board realized that negative 4 and 2 would divide each other. Negative 4 divided by 2 is negative 2. That's your answer. Here's our next problem. We got some board buddies. Somebody didn't come up. Oh, we need one more. Gabe, you're up. Now you need some board buddies. You need 5 guys to break from this jail to make yourself some trees. Maybe. What I would actually do is check to see if 243 is a perfect fifth root. Because why would you make a factor tree if 243 is a perfect fifth root? Quick. Alright, hello people in the video. We lucked out and 243 was a perfect fifth root. When we typed in the calculator, we just got 3, so you can put the 3 out of jail. Then we had to do a little long division. 8 divided by 5 is 1 remainder 3. 1 remainder 3. And that just means that 1A gets out of jail, 3 A's remain in jail, like so. We do the same thing with the 9. 9 divided by 5 is 1 remainder 4. So 1B gets out of jail, 4 B's run in. Okay? So, any questions on that one? Good job to make people at the board. Looks like they all got it. Alright, on this one we were looking for 2 guys to break out of jail. We found 7s that could come out. And then it's just your long division. Keep in mind there's a little 2 here. So 6 divided by 2 is 3, remainder 0. 3 x's get out, no x's remain in. And 5 divided by 2 is 2, remainder 1. So 2 y's get out, 1 y remains in. There's your answer. Questions on that one? Alright, so in this one we made the radical 2 and radical 7 separate, just to see the numerator separately from the denominator. And then we used a radical 7 on the top and a radical 7 on the bottom. These 2 together become radical 49. If you need to write that out, you can. And the square root of 49 is 7. Alright, number 5, you need 2 guys to break from my jail. Just peeking at what people put on the board. They went with 82 and 2. And then I want to pick on this person right here that used the black marker. Right at this point is when you should have stopped. If you only need 2 guys to break out of jail, why did you go down to all your little 3s? Do you know what I mean? So just partner up the 9, bring a 9 out of jail. Save your time with all those little 3s. That's what I'm going to do. Partner up my 9s. He's in the hole. He's out of jail. If the negative 2 is out of jail and the 9 joins him, they multiply together. That 2 stays in jail. So here's my final answer. Does that make sense? I mean, you're not wrong if you go all the way down to all your 3s. But if you can partner up bigger numbers, partner them up. Okay? I talked on the video a little bit. Hello, people in the video. I made it a challenge myself that I don't want to be partnering up a billion 2s. I mean, if you're into that, do it. But I was like, maybe I can partner up 4s or 6s or 8s or something bigger than a bunch of 2s. So that's what I did. I made my factor tree 64 and 4. And then 64 is 8 and 8. And then 4 and 2 and 4 and 2. And I got those 3 4s that I needed to partner up. 2 fell in the hole. 1 lived. So that one that lived got out front. And then this 2 and this 2 stayed in jail and remultiplied together to become a 4. All right, we kind of partnered up the 6s, got a 6 out of jail, left a 3 in jail. If you did end up going to the 2s and 3s, not a problem, but you'll get a 2 out of jail and a 3 out of jail. Number 2. So So longhand division. 20 divided by 5. 4. Remainder, 0. And that just means 4. No, sorry, 5. Wait. Let me try that again. Of course I'm on record and I messed it up. 20 divided by 4 is 5 with a remainder of 0. So that means we get 5 M's out and nobody stays in. There's no numbers to deal with, okay?
Yeah.
All right, you just need to know where all your buttons are located. So I'm using a TI-84. I do 4 math 5 to get the fourth root. Everybody's calculator is a little different. You just have to know your calculator. I got 0.3 for part A. In part B, a lot of you that are using the TI-30s, you are going to need parentheses around that 64 and the 15625. If you're using a TI-84, you don't need parentheses, but like the TI-30s, TI-34s, you do need parentheses. So it kind of groups that stuff as fraction. 0.4. And then the last one should be pretty straightforward if you know where your button is. If you cannot find your button, please see me or see a neighbor. On part C, it's 3.6 if you round it correctly. All right, so any questions on calculator or anything, let me know. I'm going to put this video online, put all the answers online. I'll fix some study party problems online. If you're bored tonight, looking for extra practice.